With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question given here is Kp for calcium carbonate and calcium oxide and carbon dioxide. So this is the reaction given here, and the Kp value for this is given, that is 0.5 at 1000 Kelvin. Then 2 moles each of calcium oxide and carbon dioxide, each at 0.45 atmosphere, introduced in a 16.4 liter vessel and heated up to 1000 Kelvin. The amount of calcium carbonate formed here will be, as this is, there would be an equilibrium established in the reaction. So we are given here with the moles of calcium oxide and carbon dioxide, and the question is asking about the amount of calcium carbonate. So we can write the reaction like this, that is calcium carbonate solid is in equilibrium with the calcium oxide along with the carbon dioxide molecule. Okay, so here the carbon dioxide only is in the gaseous state and the calcium oxide and calcium carbonate is in the solid state. So by looking at the reaction only, we can say that the Kp value which is given for the question is actually for carbon dioxide only, because none of the other constituent is in gaseous state. So Kp value is given here is 0.5. So we can take it as the pressure of carbon dioxide only. Okay. Now let's see the reaction here. It is told that 2 moles of calcium oxide and 2 moles of carbon dioxide are present initially at time t is equal to 0. Now what will happen at the equilibrium? Equilibrium, we can assume that x moles of calcium carbonate are also present in the solution. Then we can say that the 2 minus x moles of calcium oxide would be left in the solution. And for carbon dioxide also, 2 minus x moles of carbon dioxide would be present in the solution. So we are given here with the Kp value, then temperature is also given to us, then we also know volume. So let's write all these values here which are given in our question. That is, volume is 16.4, then temperature given is, that is 1000 Kelvin, and it would be liter. Then we know the value of R, that is 0.082, okay, and we know the pressure, that is 0.5, that is atmosphere, 0.5 atmosphere. So we can use here the ideal gas equation. What is the ideal gas equation? The ideal gas equation is PV is equal to nRT. So we can get an expression for N here, that N is the number of moles. Okay, so we have to calculate the number of moles here, and we can modify the expression like this, that is PV divided by RT. Okay, so by putting the values here, we can get the expression, or you can get the value of N, that is the number of moles. Pressure, let's put the value, that is 0.5, into temperature is, that is, sorry, we have to put here volume, not the temperature. The volume is 16.4, then divided by R value, that is 0.082, into temperature is given, that is 1000 Kelvin. So on calculating these terms, we can get the number of moles, which are 0.1 here. So number of moles of carbon dioxide we have calculated, isn't it? Because we have used it for carbon dioxide, which is in gaseous state only. Other constituents are not in the gaseous state. That's why we calculated by using this formula the number of moles of carbon dioxide. Now in the expression it is told that number of moles of carbon dioxide left over at equilibrium is 2 minus x. But that value we have calculated to be equal to 0.1. So can we get the value for x from this? Yeah. Therefore, the x value comes out to be, that is 1.9. So we got the value of x. What was the x? X we had assumed that is the number of moles of calcium carbonate formed at equilibrium. So let's check in the given options which option is giving us this value. So option C is giving us this value, and which is a correct answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.